unas palabras de introducción en español. Encantados de hacer este training para ustedes y vamos a hacerlo en inglés, como explicó Martín justamente. Y ahora doy la palabra a mi colega Han Admiral. Please start our introduction.
Thank you, Antonia, for your very clever introduction in Spanish. I'm afraid you'll have to do it in English with me. Good morning, everyone. We hope that we will be able to give you a lot of information in the coming 2.5 hours. It's quite a lot, so just sit back and enjoy yourselves. I would say. Let me just.
Also, from my side, we've designed it in a way that it's that we have prepared a lot of interesting content for you with a lot of hands-on practical examples, also some video material. And here Han is showing the program overview. So we're starting now with a short introduction on who we are and what Ithacus is doing and who we are. And then Han will give a session on I will give a session on urban underground sustainability. And then we will have a very interesting session on underground urbanism and historical approaches by Han. And we will then take a short break. And then we will discuss planning aspects for the use of large-scale underground spaces. And we will have policy building and a session on spatial design. And we want to have also a question and answer session with you at the end. Hopefully there will be time and hopefully you will still have energy for that.
Thank you, Antonia. And Martin just said that Ithacus does develop all kinds of materials. And one of the things that we produced was a video which was basically aimed at the mayors of large cities. But I think it's a very appropriate way to start this training because it will help you with getting a totally different idea about what it is we can do with underground spaces. So this video should come now next.
Our city mayors, public policy leaders and our planners face many challenges in the next 40 years. Margareta Wallström says, unless we act now, we will see more and more disasters due to unplanned urbanization and environmental degradation. Juan Clos echoes that, saying we need to demonstrate that change is possible through the genius, creativity and audacity of people and decision makers to make the wisest choices for our urban future. Imagine a city with a historic centre, a city with planning legislation prohibiting the demolition of heritage buildings, a city with height regulations limiting new buildings to 8 floors. Imagine that historic city centre needing new social and transport infrastructure, living and office space, leisure facilities. Where would you find the space to fit all this in? You'd find it here, in the Earth Scraper, a 65-floor deep, inverted skyscraper. This is all the space you need with no compromise on the existing urban fabric. The Earth Scraper is an inverted pyramid with a central void, allowing all underground habitable space to enjoy natural light and ventilation. In the last 30 years, the world has had to cope with nearly 3,500 floods. Intense rainfall is now a major hazard for cities. So imagine a city with a thriving central business district, but one that is flooded on average once a year, severely disrupting commercial life. How can you prevent this? In Kuala Lumpur, you do it the smart way, with an underground solution combining both a road and a stormwater management tunnel. Next, imagine a city under threat from major earthquakes. A city that has previously experienced the collapse of its vital infrastructure, severely hindering disaster relief efforts. Now imagine that same city making use of resilient underground infrastructure, much less susceptible to earthquakes. A city where even after a major quake, essential aid can be distributed and life protected. As the world's population increases, our cities are becoming increasingly overcrowded, the available space almost all taken. But cities must be livable to be loved. They need open and green areas, public spaces for a society to enjoy. Imagine creating those spaces below the surface, parkland beneath the urban centre. Meet the Low Line, a private initiative in the Lower East Side of New York City, reusing an unwanted, forgotten underground tramway depot and giving it new life. Now imagine your city using its underground space, becoming more resilient against natural disaster and the effects of climate change, developing sustainably through the use of geothermal energy, integrating surface and below surface development, creating new connections and increasing livability, rapidly transporting people through underground systems that double up as cargo and disaster relief infrastructure. We know about underground space. Now you know too.
And I think the video sums it up quite nicely. Why cities should know about underground space, and it is all about imagination. We've used some examples like the earth scraper, and it's always been a big hit with the general public. If we show it to engineers, they always question whether you can actually construct something like that. But when it comes to underground space, we really need to look at it from a different perspective, which is what Antonia and I have been doing when we wrote our book, Underground Spaces Unveiled, but also what our committee, Ithacus, is all about. Antonia.
Yeah, precisely. So Han and I have been co-leading the Ithacus committee for a long time, but Han has actually initially founded it even before I joined the committee. The committee is really about a multidisciplinary approach to addressing the challenges our cities are facing. And we firmly believe that the subsurface or the underground space has a very important role in playing and we need to therefore strategically plan our cities, including the subsurface. And that's what our committee is about. Here you see our various activity groups. We have a very multicultural, multidisciplinary team working with us. We have a young professional Think Deep program, which you see on the top left, which is really interesting for any city or community worldwide that wants to study or analyze and find solutions to an urban problem, where underground solutions could be part of the solution. So we deploy teams into various cities. We have one coming up in Athens, preceding the World Tunnel and Underground Space Congress, which will take place in the spring. And if you attend this Congress, you will hear presentations from that one. We also have scientific ambassadors, which you see in the middle. A scientific ambassador and a young talent ambassador, Mauricio Alvarez. He's from Colombia originally. So if you want to connect and know more, contact Mauricio. Also, we have 3 wonderful activity group leaders who work on urban adaptability. Mahak from India, Chrysothemis from Greece on urban sustainability, and Marilu Melo from Mexico, residing in Australia. And maybe also very important, our National Action Think Deep program, which you see in the bottom in the center, led by Abidemi Agwor from Nigeria and Britain. And that's really about bringing Ithacus to a national level. So where we help countries come up with Think Deep programs. And these have been developed in Nigeria, in Australia, and in the UK, as well as in Sweden so far. Here a bit about our book, which Han has mentioned, Underground Spaces Unveiled, Planning and Creating the Cities of the Future. It was published by ICE Publishing, the Institution of Civil Engineers in the UK. And you find the QR code here to our book homepage. The book is really about a lot of the topics that we're also covering today, but of course in much more depth and with a lot of hands-on practical case examples, but also underlying theory that's very interesting if you're in this field. And maybe if you're a student or you have an employer that can get the book, it's also available virtually.
Okay, and I think that's about it. Oh, our vision, Antonia, we nearly forgot about our vision, which is basically the next level up is down. We truly believe that in all the challenges that cities are facing worldwide, we really cannot discount what is happening below the surface. And that is what our presentations are going to show you. They basically will talk about what we can use the subsurface for, what we need to look out for, but also show you how thinking has evolved throughout the years on the use of underground space. And that's about it for our introduction. So I'm going to stop sharing this presentation, Antonia, so you can start with your presentation.
Okay, let's do this. Our first contribution is on urban underground sustainability. So what's important in achieving urban underground sustainability is really the harmony between humanity and nature, between conservation and exploitation to achieve a good balance. And we have studied quite a bit in the ITA Committee on Underground Space, Ithacus, how do we achieve the global goals for sustainable development? And how does underground space use contribute? And how do we achieve this balance, as I said, between the needs of humanity and our growing cities and the needs of nature and the preservation of our ecosystems and biodiversity, for instance. You all know how the pressure on cities and urban development is increasing, especially I think in Latin America, it's a big issue. And underground space can provide sustainable and resilient solutions for our cities. And ultimately, our urban areas that are resilient are also ultimately more sustainable, and we will show you why. So the global goals for sustainable development there are 17 in total, and I'm sure you're familiar with them because everybody's now paying attention to this increasingly, even on a company level and on an individual level. How does society contribute to these goals? And we are looking here at which projects are already contributing and how, and what are future possibilities of cases that are now still at the initial proposal level or that are currently being prototyped. Because as you know, there's so much going on in the field of environmental protection, but also renewable energy in that field. And there's so many interesting technologies and solutions being developed. And some need to still see the light of day in terms of actually making it beyond the prototype, but also by becoming mainstream policy in cities and countries. So here you see an overview of the 17 goals, and each one of them is important, and one cannot say one is more important than the other. But as far as we're concerned, number 11 is a big one that we're focusing on, sustainable cities and communities. But also, as you will see in my next example, for instance, 7, affordable and clean energy, also 8 and 9. But you will see, I will include even other examples, like for number 1, number 2, zero hunger, and number 6, clean water and sanitation. So these are the ones that we've looked at in our book, Han and I, and where we've come up with specific examples how underground space contributes. However, meanwhile, other authors have identified even further ones. And in fact, the ITA president 2 weeks ago in the British Tunneling Society's conference showed that all of them can actually contribute. So we will bring a few selected examples for you to really highlight the point how important the subsurface is in the development of our cities, but also in terms of achieving the sustainable development goals. So here, zero hunger. What does zero hunger stand for and what does it want to achieve? So it's about ending worldwide hunger and achieving food security and improved nutrition, and also promoting sustainable agriculture. We need to ensure sustainable food production systems and implement resilient agricultural practices. And it's supposed to help maintain ecosystems and at the same time adapt to natural disasters like extreme weather, droughts, flooding, but also to the overall issues of climate change that we're facing. And last but not least, to improve land and soil quality. And if you look at these examples, these are actually 2 underground green farms. The left one is, you see mini lettuces growing here, but this was at the initial stage when they were first planted. However, this is in part of the a pilot project in the Hagerbach Test Gallery in Switzerland. And Ithacus is actually partnering in this effort because we think it's absolutely crucial to demonstrate how life below the surface is possible, and not only possible, but is really also beneficial to society overall. So, for instance, on the right, you see an underground green farm that is already in existence. That's in an underground bunker in the city of London, in a now underutilized space. And it has been developed from a small startup project to a really quite substantial business that is now catering to the market, the borough market in London, which is famous on top. So there's no transportation needed. The food gets delivered straight from under the earth to the market stalls on top, but also to the trendy restaurants in the area which want to have sustainably farmed microgreens. And what's so interesting about these greens is that there's amazingly many harvests possible a year because you don't have seasons. You can exactly steer how much light these plants get, how much humidity, and you can basically have a harvest of these microgreens every 2 weeks. So this is food grown under artificial conditions, but there are substantial advantages because it's not prone to bad weather. And underground, we have constant temperatures. So they're stable, they don't vary, they don't fluctuate. And that's why the several harvests are possible. And I've just shown you a couple of examples, but increasingly also underground green farms are being created in metro stations in cities. So for instance, in Seoul, there is a very famous one, but also in Stockholm. And what's so interesting is these are maybe underutilized spaces, but they create actually food for our society. and they can really significantly substantiate and supplement what is grown on the surface. And not only that, but it can be grown pesticide free and with 70 to 80% less water. And that's crucial in the future because A, we don't have space, B, we don't want food grown with pesticides, or we don't want destroyed harvests, crops that have been destroyed by storms or other natural disasters. And so these are really interesting solutions that we need to look at. Here you see Han explaining the zero hunger concept in a short video. I'm skipping through this right now because I've basically already said that. And also in light of time, but you're welcome to see this afterwards. We've actually also created a movie about this, and I think it's included in the sources in the back. So the next example is clean water and sanitation, where we need to, by 2030, we've committed to achieving universal and equitable access to safe and affordable drinking water for all. And we need to also provide adequate and equitable sanitation and hygiene, and improve water quality by reducing pollution and increasing the efficiency of water use, because we're wasting liters and liters of water on a daily basis in an urban environment. So what can the underground space contribute here? For instance, storing water in underground aquifers through rainfall infiltration. So when it rains, that we actually collect this water and not just let it run off. And we can also capture it and reuse it as gray water. That's being done in some interesting buildings and facilities now, where we actually don't need completely fresh water just for flushing the toilet. So we use gray water. Then freeing up space on surface for green areas and making infiltration possible. I will show an example of that. And of course, we house extremely important drinking water and wastewater pipelines underground, as well as aquifers. So let me give you one example from Mexico. So it's a 60-kilometer long water transfer system, the Emisor Oriente. And it's one of the largest systems of that kind in the world. You see here the dimensions and the length and the capacities and the shafts needed to construct it and so on in the graphic. And what it does is really like bring the wastewater of Mexico City to the water treatment plant 60 kilometers outside. But at the same time, it has been designed also for runoff of rainwater. And that really helps Mexico City to alleviate the flooding. And this whole system was built because the former system no longer had the capacity. And that's actually the case in so many cities now that build deep sewage systems and increase their water transfer and water runoff systems, because the cities cannot cope anymore. Then SDG 7 is about affordable and clean energy. And that's really about ensuring access to affordable, reliable, sustainable, and modern energy for all, and to ensure universal access to that. To also increase substantially the share of renewable energy in the global energy mix. That's such an important issue right now. In Europe, we're dependent on to a large extent on, for instance, the gas coming from Russia. Also, we're building back nuclear reactors. We don't want nuclear energy anymore. But where do we get our energy mix from? Where is the sufficient mix or the sufficient capacity of renewable energy? I, for instance, live in Switzerland. We're lucky we have 2/3 of the energy is derived from hydropower plants. But of course, and maybe in the Netherlands where Han is living, they're doing a lot with wind energy. But increasingly, we really need to look at clean sources of energy. So the underground space, again, has a vital role in this. One of the aspects is, for instance, geothermal energy that can be derived from the underground, where we actually go into the deep underground space and derive hot water directly out of the earth. And we also have very interesting aquifer thermal energy storage systems. For instance, the Mine Water project in the Netherlands that you see here in the graphic, which is a former miner shafts and galleries. So it was it was the largest mine in the Netherlands, and the galleries and shafts are no longer used. So partially now it has been reconverted into a source of renewable energy in terms of hot and cold water storage systems, and bringing up the hot water in the cold season and the cold water in the hot season, and providing energy efficient energy for the community on top. And these kind of systems cut the need for fossil-based energy, obviously. And this particular one, for instance, reduces the overall CO2 emissions for heating and cooling by 65%. So that's really an impressive number that we need to work towards. We have also the SDG 2, which is decent work and economic growth. How does underground space contribute? Well, here's an example, for instance, the Rectory Farm in the UK, which is in the outskirts of London, actually near Heathrow Airport, where gravel is being extracted. So it's an important source of gravel. And but at the same time, rather than doing an open pit gravel extraction mine, the local community and the investor and the involved stakeholders came up with a concept where they're actually using the underground space also as a major warehousing and logistics facility, and storage and so on, apart from extracting the gravel, which creates actually 2,500 jobs in this rather deprived neighborhood of London. And believe it or not, creating several acres of parkland on top. So this is, of course, a win-win. You extract something, you're contributing to decent work and economic growth. You're creating labor places, but you're also creating park space on top for this deprived community that was actually urban wasteland before. Industry, innovation, and infrastructure is SDG 9. And there are a lot of interesting projects that really look at how can we use the underground to contribute to innovation and infrastructure. Here's, for instance, one that's like in the very early planning stage, but a whole metro ring is envisioned around the lake of Zurich, where I live, which is now an overground rail line, and which kind of dissects the communities living around the lake with the lakefront. And this metro ring could, of course, provide very interesting mobility at a much faster speed and capacity, but also create a new linear park around the lake. And here, this is quite an interesting one, where you see how underground space can also contribute to transportation policy. And you see here how many people get moved by which mode: in a car lane, in a bike lane, in a sidewalk, in a transit way. And look, I mean, it's 10,000 to 25,000 people per hour can be moved in a sort of usually underground metro system. So in that sense, SDG 9 can definitely be contributed to by underground systems. And SDG 11, which I've mentioned also in the intro, sustainable cities and communities. where we want to achieve harmony between humanity and nature. This is really based on the World Commission on Environment and Development, and the Brundtland report, which was actually written in 1987. And we're saying here, what is the role of the subsurface? So it's our foundation of life and includes resources that are actually non-renewable. So once we take out these resources out of the subsurface, we cannot replenish them. And that's why it's so important that we balance the exploitation of the subsurface with the conservation of it. And therefore, we need a framework for sustainable underground space development. A quick overview of the 5 principles of ecological infrastructure, according to Hillary Brown from the US. So she says you need to really fulfill 5 factors towards achieving sustainable cities and communities, which is you need multi-purpose on mixed land use. You need to reduce energy and greenhouse gas emissions. You need to include green infrastructure. You need to deliver social and economic benefits to surrounding communities. And you need to contain climate adaptation measures. And for instance, this building here in San Francisco, the Trans-Bay Center, is one that fulfills all that. So all of these that I mentioned here, multi-purpose, mixed land use, reduce energy, include green infrastructure, deliver socioeconomic benefits, and contain climate adaptation measures, is all part of this building, which is a transport hub. As you see in the 2 underground levels, people moving, commuting, buses coming in, taxis coming in, cars coming in, but also, of course, the local and regional train system. And then you have leisure areas, but also office spaces, and especially it connects to the surrounding offices. And most importantly, it includes a park on top. So it actually absorbs CO2. This shaft brings in natural light, but also natural air. The whole building is extremely energy efficient. And so these are the concepts that we really need to look at for our sustainable cities and communities. Here you see another graphic of the building. And we also have it described in our book, because we find these are the concepts that cities need to deploy. By the way, it's also capturing rainwater and using it for gray water in the whole building, which I've mentioned before. And maybe another example, we've talked about infiltration and water treatment. So this could also go under SDG 6, but this at the same time provides something towards sustainable city and community. So this is actually a golf course on top in the Bronx, New York City, but it's actually a water infiltration plant, and water is being treated and cleaned underneath this golf course. So these are really interesting examples where you couple uses and you provide a benefit from a natural and environmental and social point of view. And maybe a quick word about the model that Han and I have come up with to appraise urban underground development, where how do you actually appraise a project like that in terms of, do I benefit and do I contribute toward SDG 9? So we look at the underground space development itself, which you see in the center, then how it interacts with other underground structures. Then we look at the impact on the ecosystem services and on the suitability of the subsurface overall. And that needs to be looked at in past, present, and future. And it's really a 4-factor approach combining all these important aspects of geological, ecological, planning, and environmental considerations. And for that, the knowledge of the suitability of the subsurface is extremely important, but also of the long-term impact on the surface. Another example that is interesting is the wafer fab chip factory in Switzerland, where a developer wanted to produce chips in a completely vibration-free environment and wanted to build a factory above ground in a small community in the Rhine Valley in Switzerland. And the community was opposed because it would have needed extremely large foundations, and it would have been an extremely boxy building, kind of scarring the landscape. So Amberg Engineering, who was the designer for this project, said, please go underground and look at the underground solution. And this developer actually managed to not only cut costs by going underground, but also provide something that is a contribution towards this community in a sustainable way, because it was not affecting any surrounding infrastructures. It has no impact on the surface. It creates labor, like the examples I showed you in the UK. And it can also be converted to something else in the future, which is important in designing underground spaces. So another very important one, SDG 13, climate action, something we're all super concerned with now. One of the biggest issues facing humanity, and our cities are especially concerned and affected. Most of our mega cities are coastal cities, and they're prone to floods, susceptible to erratic weather patterns, to heat, to drought, flooding, and storms. We hear it in the news all the time. And underground space can provide sheltered areas and leaving transport and emergency relief unencumbered, which we've seen in the video, in the Imagine video in the beginning. So if we design the underground spaces and underground infrastructures with a view to that, we can really have sheltered areas and emergency relief when needed. And resilience is a big part of climate action. And resilience is really the capacity of individuals and communities and systems to survive, adapt, and grow in the face of stress and shocks, and to transform when required. And building resilience is about making people and communities and systems better prepared to withstand catastrophic events, whether they're natural or human-made, and to make them able to bounce back, to come back more quickly and emerge stronger from the shocks and stresses. So the SDG 13 says we need to help mitigate shocks and stresses. And for instance, earthquakes and floods and the heat island effect, the underground space can help because it has the capacity, for instance, for storage of rainwater. It keeps us more sheltered in earthquakes. And we have some very interesting examples, for instance, from Rotterdam or from Kuala Lumpur, where we serve transport, but we also alleviate flooding. And maybe also on resilience, here, for instance, you see the plan for Boston 2070, their strategic plan, how to combat climate action and be more resilient. And you see what they have planned. Elevated transportation corridors, flood resilient buildings, strengthened seawalls, stormwater collection points, expanded tree canopy. And this one doesn't include the underground space. But what we are saying is cities need to look at their underground space in addition and see how that can be factored in to make themselves more resilient. So in conclusion of this first part, underground space is a major strategic asset of cities worldwide, and ensuring our development efforts that they happen in a sustainable way, we need to plan and optimize the underground development. And underground space can help achieve at least 7 of the 17 Sustainable Development Goals as defined by the United Nations, like I showed you now in some hands-on examples. And it can also make our cities more resilient and able to withstand shocks and stresses facing us. And I want to thank you and maybe see if there are some urgent questions, and if not, we can also take questions later. And I would otherwise hand over to Han, who will give the next part.
Yes, Antonia, there are no questions at the moment.
Okay, perfect.
So you can
perfect.
continue, please.
Okay, excellent. So I've stopped sharing, Han.
Yep, I'm going over to my presentation. So thank you, Antonia, for talking us through this very important topic of how underground space use can contribute to the Sustainable Development Goals, but also when we are looking at developing the subsurface, how we must try to do that and try to balance the needs of humanity versus the needs of the subsurface itself. So we need to also carefully look if we're not kind of destroying things that are below our feet and that are supporting the life on the surface. What I want to be talking to you about in these next 30 minutes is about giving more or less a historic perspective, and we've called it From Yaodong to the Third Dimension, because that's really the span of the development. The Yaodongs, as we will see in a minute, go back a long time. They were already there long before the common era, and the third dimension is a way of thinking that has come into urban planning in these past 20-30 years. So to start with, let's go to the Lust Plateau in China. It's also known as the Yellow Earth Plateau. It's the origins of Chinese habitation. And we can trace it back, human settlements, as far back as 210 before the Common Era. And there are two typical archetypes of settlement, those that are sunken into the earth and those that are carved into the hillsides. And I will show you those to you in a minute, and then also kind of show how we've taken on those ideas when it comes to the underground spaces, the more contemporary underground spaces that we are creating nowadays. So sunken into the earth and carved into the hillside. So this is the Lust Plateau, which is in itself very bare. There's a lot of wind, and the surface conditions are not very ideal to stay or live on the surface. So that basically then made that people started digging into the earth and creating these kind of sunken atriums from which they then carved out all kinds of rooms and corridors. And the interesting thing is that these Yaodongs have been there for a long time, and it's certainly not something that is only for historic purposes. They are still in existence. They are still being used nowadays. They have been modernized, of course, a little bit, but the principle is still there. And one of the most interesting ideas that we can take from the Yaodong is that you can see that the atrium, which creates the entrances into the spaces that have been carved out into the subsurface, the trees that are planted there, you can clearly see on this picture that there are trees or shrubs down below, and they kind of give a connection to the earth, to the surface, which is very important. And we'll see that coming back in some of the more modern day examples that I will give later on. So if we look at modern day equivalents into the sunken into the earth idea of underground space, I'll talk about two examples: the Artes Underground School in Arnhem in the Netherlands and the Gangnam International Transit Center in Seoul, South Korea. So this is the underground school in Arnhem in the Netherlands, and basically what we're seeing here is the roof of the facility, which is just coming out onto the surface. It's about 0.5 meter above the surface. The reason that they went for an underground space solution in this instance was that the original building had been designed by the renowned Dutch architect Rietveld, and there was no modern day architect who wanted to compete with Rietveld in designing a building next to it. So that was one reason that they said, well, can't we do something underground? The other one is that where you see the trees on the right-hand side of the picture, that is the front edge of the what we call the Veluwe Massif. So that is an area of protected natural beauty. So it wasn't really allowed to build any new buildings in front of that. So two compelling reasons to go below the surface. And this is a school scene from the inside. You can see the roof, which we just saw on the outside, and you can see the building that is basically just sunken into the subsurface. It's a bit like the Yaodong, only it has a hard cover, if you like, and you can see the rooms on the which are placed there where the music lessons take place or the ballet lessons are given. And also notice that the windows have been placed in such a way that when people are inside those rooms, they can look out of the windows, and through the windows they look out through the roof to the outside. So there's this constant contact with the outside, which basically means that when you're inside that building, you don't really feel like you're below the surface. And I think that's a very important design aspect as well. Here is the proposal made by Dominique Perrault, a French architect, for the Gangnam International Transit Center. You can see it in the middle of the picture. It's basically a light line, if you like. It's a glass walkway on which you can walk, but at the same time, it serves a purpose of letting in light to the world below. And this is how the world below has been envisaged by Perrault. You can see how the light comes in through the canopy again, not unlike the underground school we just discussed. But you can see that there's really a very high quality area being developed below, connecting various transit services, a bit like the example that Antonia showed from San Francisco, but much more elongated. But the main point being that we can see the basic concept of the Yaodong. We can see it back in the way that we're using the underground space here. And here again, just another image of how it will look like when it's completed. So this is still under construction in South Korea. But the Yaodongs not only go into the earth with these sunken atriums, as we saw, we also have Yaodongs which are carved into the hillside. So basically, they are human-made caverns, if you like. And this is the same development we can see in Hong Kong, Singapore, Norway, Sweden, and Switzerland, where the excavation of material from inside the hill is actually quite interesting, because it provides building materials which have a value which you can actually sell off. And then in doing so, in getting the material out, you create these underground spaces, which again have a value in terms of real estate. And again, Antonia already demonstrated that principle with the Rectory Farm project. And here just an illustration from Hong Kong, where basically they just show how we can create spaces inside a hill or inside a mountain, which can then be used for various purposes. Here you see, for example, the Stanley sewage treatment works, which people actually regularly visit because they find it fascinating that these facilities have been placed underground. But at the same time, I think the point about, and just going back to this image, the point about creating these caverns is that the use of those caverns can actually be independent from the space that has been created. So even if you place a sewage treatment works inside that cavern, if at any time those treatment works are not needed anymore, you can take them out, and the space that is left there can actually be repurposed for something else. And this is all another important principle when it comes to anything that we create below the surface, or any underground spaces that we create. We need to think about how can they be repurposed for other functions, other uses over time. So in Norway, there is the Gjøvik Olympic Hall, which is created inside a mountain, which is used, basically it was built for Olympic sports, for ice hockey, but at the same time, you can see from the picture above, it can also be used as a music hall where you can give concerts. So there's this multi-purpose use of the space. And interestingly enough, they call this the architecture of insertion. So let's move to a bit back into history, into the 19th century. And this is the Semmering Railway in Austria. And yes, that railway includes tunnels that run through mountains. But the real reason that I'm showing this is that it was actually, when it was built when they started building it in 1848, it was really a major challenge for engineers. And the challenge was that the railway had quite steep gradients, and the gradients were such that none of the existing engines, train engines, could actually use or conquer those gradients, if you like. And the engineers that started work on the railway said, look, we're going to build this railway because we really believe that by the time we're finished, someone will have built an engine that is able to take these gradients, and indeed that is what happened. And you can see this kind of optimism that they had in those days. There was a kind of unrivaled optimism as they discovered that they were able to build tunnels, and engineers started to come up with ideas for a tunnel below the Strait of Gibraltar. They wanted an iron tunnel below the Bosporus. They wanted a tunnel under the Son to connect Denmark with Sweden. And in reality, it would take another 100 years before those projects really became reality, and some are still on the drawing board. So one of the things that we need to do when it comes to all these underground space ideas that we have, we need to be able to convince people that these are good developments, that we really need these kind of developments, and that they are good for humanity and for the future of humanity. Isambard Kingdom Brunel, who actually more or less invented the shield tunneling method and built a tunnel below the Thames in London. That tunnel was flooded multiple times, and in 1827 he actually held a banquet after the tunnel was the water was taken out again. He actually held a banquet there for his investors to show them that all was well, and that he was still he still wanted to continue the work, and was really convinced that he could complete the tunnel, and he did so. And interestingly enough, in I think it was in the 1990s, when I was project manager for the first TVM-driven tunnel in the Netherlands, when it was completed, we also had the same kind of dinner in the tunnel for everyone, just to show them that it was really safe. But we already knew that, but we really thought it was very interesting to kind of repeat Brunel's banquet. But what it really means is that a lot of the ideas that we have, and a lot of things that we are enthusiastic about, kind of have the Jules Verne effect. And the Jules Verne effect is that we have a brilliant story, but that our timing is very often lousy. You can see that from the image on the right, which is Jules Verne's image of a rocket that could carry people to the moon, and the image on the left, which is the one that Elon Musk is building. And they show they're actually quite similar, but it's taken a long time since Jules Verne first mentioned going to the moon, and we're actually went there, and now again we're thinking about going there again. So one of the things that we need to learn when it comes to underground space development is it's not just that we need to get the story right, we need to get our timing right as well. And that takes us into the 20th century, when in Paris we saw a lot of underground space development. It was Georges Eugène Haussmann who really developed Paris as we know it today. And he kind of, in his memoirs, he wrote about the underground galleries that he had been designing and building. And he saw these underground galleries would be like the organs of the metropolis and function like those of a human body without ever seeing the light of day. Pure and fresh water, along with light and heat, would circulate like the diverse fluids whose movement and replenishment sustain life itself. And what we see here is really that people started to think about using the subsurface, but using it for in many ways like the engine room of the city. Eugène Hénard, who came later in 1910, he made an observation where he said, look, our thinking is totally flawed. We see the bottom of the road as like the absolute level between surface and subsurface, but if we place it on a level with the ground in its original condition, then there's not much we can do. But if we actually raise that level, and you can see that here in some of the drawings that he submitted at the time to the Royal Society, you can see he's actually raised the street and created an elevated street. And in doing so, he created all this space below the street for services, basically little cars with coal and other kind of services that he thought the houses of those days required, and it also tied in with houses. And you can see here on the right of the picture even storage for cars below the surface. And indeed, if we now look at places like London, where the rich people are actually extending their houses downwards, the so-called iceberg mansions, you can see actually the ideas that Haussmann had, or sorry, Hénard had, you can see them still being used. But he came up with a clever idea. He just said, like, you know, let's raise the street level and then build below that. In 1914, it was George Webster in the United States. He worked for the city of Philadelphia. He said little thought has been given to the planning and laying out of underground streets. And he talked about the subterranean street, where he saw a massive use of the subterranean street for all kinds of services. I like the way that he also proposed the connections for refrigerating pipes, for example, and steam and hot water pipes, which is not very far off the district heating systems that we now have today. But he said, look, you know, if we're going to have all these uses, then if we don't plan that, if we don't ensure that the spaces are there to be used, and we do this in a logical way, it's going to become a chaos. So this was in 1914. It's over 100 years ago, and we're still struggling with the whole concept of planning the subsurface. This is a modern day example from Sweden, the city of Linköping, where they are building a new extension of the city, and they've put a so-called infratunnel into place. And this infratunnel basically carries all the elements that Webster summed up, and they're placed into one big tunnel, which was prefabricated, put into place, and it's basically 3.5 kilometers of tunnel into which all the cables and pipes can be placed that are needed for the urban area and that serve the urban area. And rather than haphazardly placing them all at random below the surface, they've been put into this infrastructure collector, which actually makes access to them a lot easier, maintenance a lot easier, and you don't have to disturb the soil every time to make space for a new pipeline or cables. And here you can see how the concept works. Interestingly enough, the actual tunnel part is actually a big plastic pipe, which also says something about the development of material science. Moving on to the 21st century, we then saw that we started to really think about the development of the subsurface, and there was a first International Congress of Underground Urban Development in Paris in 1937, and it was Edouard Outoujian who was really the promoter of this Congress, and the promoter of starting to think in a more rational manner about the underground. And one of the things that he said was that the chaotic side of our congested cities, along with the ever-increasing use of the underground for urban functions, have inspired us to look to the subsurface for remedies and improvements to the multiplicity of ills from which our great urban centers are suffering. In addition, we would like to introduce order and discipline to this immense field in which a great number of the life support arteries of the city are haphazardly buried and tangled. So he kind of came back to what Webster already said in 1914, and he added on to this. But still, we are still thinking about using the subsurface as this kind of engine room for the city and placing all the things that we don't want to see above ground and place those below ground. Rather, underground urban development must contribute to better utilization of urban space by hiding underground the various city systems that are a nuisance and an encumbrance when placed on the surface, placing them where certainly high-rise structures cannot be considered. And then on cross-discipline collaboration, he said, above all, the underground urban developer's role will consist of overseeing an harmonious interdependence and coordinating the entire body of data in order that researchers and artists, scientists and technologists can freely endow this field with their richest and boldest creations. So he really had a vision about using the subsurface, and he laid out the vision in his little book, L'Urbanisme Souterrain, in which he came up with various ideas on how to utilize the spaces below cities or using it in mountains, and not unlike again the basic concept of the Yaodongs that we saw at the beginning of the presentation. In 1952, he really wrote something very important, and we called it Outoujian's planning appeal. And he said it is necessary that the urban planner thinks deep and that underground development of cities is done not through random necessities, but according to a definite commitment, legislation, and a predetermined plan. And here you can actually see the development in his thinking, that he's coming to the point where he says, look, the urban planners need to start thinking deep, and we need to look at the development of cities in a logical and a rational way, and not through random necessities. All too often we now see that when we look at cities, how they have started to use their underground space, it is because there is one project that needs to go through, and then or a next project comes along, but we're not really giving any thought to, is it logical in the way we are doing this? So in summary, using the subsurface has a tradition which goes back long before the Common Era. We saw that from the Yaodongs, and indeed we can go even further back. We all know that humans have been using caves for a long time. We know there are other examples in Turkey, for example, Cappadocia, where even recently in Turkey a new underground city was discovered. So we have a long history of utilizing the subsurface as humans. And although the habitation was the first use, after the Industrial Revolution, the focus was on utilities, and this whole idea of creating the engine room of the city below the surface, or the urban surface layer, as we call it, that was created. And the development since has always been haphazard and autonomous. And one of the ways you can actually think about this is that if you look at the amount of underground lines that run below London, and they're all utilizing this layer known as the London clay, well, that layer is actually completely full now. They really don't know if they ever want to make another metro line under London, where they're going to place it, because the London clay obviously has a lot of advantages for building these underground systems. On the other hand, if London ever wants to start using a geothermal energy, or if they want to do something with the aquifer thermal heating systems that we saw in Antonia's presentation, they're going to be very hard pressed to do that because of the existence of all these underground lines. So the subsurface has not really been part of the urban planning, despite a lot of thinkers, including Uto Gian, arguing for it. So the underground urbanism needs to be created to ensure the urban underground space contributes to the need of cities, and to ensure that we start thinking in a different way in terms of how we use the subsurface. And the only way that we can do that is to find a dialogue between not just the engineers who usually come up with the great ideas, but we need to have a dialogue with urban planners. We need to have a dialogue with geologists. We need to have a dialogue with architects. So there's a lot of disciplines that need to be brought together. This is exactly what we're doing, as Antonia said in the introduction, with the Young Professional Think Deep program of Ithacus. And this is why, as Ithacus, we're also working closely with ISOCARP, the International Society of City and Regional Planners, to start developing underground urbanism, not from the engineering point of view or the engineering side, but from the planners themselves, and to say, look, you cannot walk away any longer from the fact that there is a subsurface, that we are using that subsurface, but that we really need to develop an urbanism that will help us to develop it even better in years to come. As the prefect of the Paris region in 1970, Maurice Doublet, he said, by imagining cities in 3 dimensions, you have multiplied tenfold the perspectives offered to those having the responsibility for planning of the cities. And I think that quote really encapsulates what it is all about, that we are moving from the era of the Yaodongs. We all know that, so that we can use the subsurface. We have ideas on how to do that, but really we need to start looking at the 3rd dimension. And this is what is really happening. And as you will hear later on in our presentations in the second part, we will not talk just about 3 dimensions, but about 5 dimensions that we need to address when it comes to developing underground spaces. And that's my presentation for the moment. If we go back to the program, I think we now have a shorter break than announced, a 10-minute break. So if we can have you all back here by 20 minutes past, then we will continue with session 2 of this training. Thank you.
Thank you very much, Antonia and Han. I saw there were at least 4 questions, which Antonia already replied. I'm not sure, but I think it can be interesting for the whole audience to have a short resume of these questions. Antonia, what do you think?
Yeah, sure. So we had questions about the social cost benefit analysis and how to appraise the social implications of such projects. And from what I remember from the question, which I can't see right now, oh yeah, what are the KPIs to measure the different social incidents throughout the project? And how do you determine if the number of social grievances are significant for the population affected by the project? And how do you help make decisions to define best practices and lessons learned? And I gave a few examples of scholarly articles on the topic, because I said there's different ways to appraise such projects, but that it can be very beneficial to include the social implications. And I don't know if Han, you want to add something to this question.
I haven't quite looked at it.
Yeah, we can also do that after the break, if you don't mind.
Yeah.
Yes, of course.
And we had another question on the infra-tunnel in terms of how many different uses there are included, and if they aren't in conflict with one another, if you, for instance, transport wastewater, but also fresh water in the same pipe. And I've also provided a source where there's more information on the infratunnel and how it's designed and what it carries exactly. But so I think the answer was given, but just in case you want to add something to that, Han, and if not, we can do that also after the break.
No, I can quickly add something. I was just looking at the question, but indeed, I think it's one of the things that we cover in our book when we talk about value capture. I think we always need to make a distinction between the actual when you do the cost benefit analysis, it's obviously it's about costs and benefits, but it's also about the social cost and the social benefits. So it's really, you also have to look at what is the value that you are creating for the city. And if you, for example, take away a certain use from the surface and place it into a cavern, and you free up space for a public park with lots of trees, that reduces the heat island effect. And obviously those benefits, you can quantify those benefits. You can even monetize them if you want to, and then use them in the whole cost benefit analysis to show that the project makes a lot of sense. But we have to make this distinction between economics, which is basically what you're doing with the cost benefit analysis, and then the financing of a project. How do we actually finance it? And what we describe in our book are various ways of how you can actually then look at how you can the value that you're creating, how you can actually capture that value and use that as part of the way to finance the project, because I think that is what we need to do. What is often done is that the cost benefit analysis is used to compare surface solutions with subsurface solutions, and obviously the subsurface solutions are always more expensive than the surface solutions, and those are not really very good comparisons, because they do not take into account the actual benefits and for the really social benefits that can come from the fact that you're placing certain uses below the surface and then freeing up space for other uses which are vital for the city to survive. So that's my 2 cents worth on this subject. I mean, we can give a total training about this aspect in itself. So, but
yes,
thank
but
you
also
for
that
the question.
The gentleman was asking what radius of action does one assess on a project? Like how do you calculate the number of people? I mean, which radius do you use? And that's an interesting question, because I think that cannot be universally answered. But in the case of a metro system, for instance, I provided a link to the example from Athens Metro, where it was first appraised in a traditional cost benefit analysis, and then the outcome was negative. But then the city came out, did also a social cost benefit analysis, and then the project outcome was positive. So it was benefiting the city. And I think probably the radius they took was the entire city, I imagine. But I don't know per se. So I hope you find some more information in the links I provided. And
yes,
and
Antonia,
then,
perhaps
yeah.
these links we will share later on, because they are
Yeah.
stored within the answered questions.
Yeah.
Thank you very much. So we will take care of that.
Okay, super. So Martin, is it okay if we do
Yes,
the 10
it is
minutes
okay.
break now?
We start with our pause for 15 minutes, and we start. Is it okay? No, now we are a little bit over the time already. No.
Yeah, I think if we can restart at 25 past, then we should still be okay overall.
Okay, in 10 minutes
timing.
approximately,
Yep.
8 to 10 minutes.
Yep.
Yeah.
Okay.
Perfect.
Seguimos en 10 minutos, entonces. Thank you.
Muy bien, nos vemos a ratito.
Gracias.